Okay, so welcome to the fourth and final video for section 7.3. So let's consider a circle of radius r not equal to 1, centered at the origin. So centered at 0, 0. Okay, so do you agree that the equation of that circle is x squared plus y squared is equal to r squared? Okay. So then, what do we have? The concentric, meaning it has the same center. The concentric unit circle S1 has equation. What are you doing, kitty? Has equation. Come on. Okay, all I need to do is, if I want the radius to be 1, I take the x squared plus y squared equals to r squared, and in order to get the radius to be 1, I'm going to divide each term by r squared, because I want a unit circle. So what I get then is on the left, ignore my kitty, he's trying to jump up. Come on. Come on. I know. Come on. Come on. There we go. Okay, so what we're going to get is x over r quantity squared plus then y over r quantity squared what color should I use is equal to 1. So this is on the unit circle. Okay, so let's draw a unit circle, shall we? So let's say we have, I think I tried to make a radius 5. Let's see if I can make a radius 5 on this thing. X and Y. 1, 2, 3, 4, 5. 5, 5, 5. Hopefully that's a radius of 5. Maybe. 1, 2, 3, 4, 5. Okay, so this is a circle of radius 5. And of course the corresponding unit circle is here. So we can see these are definitely concentric circles, meaning they have the same center. Oops. Oh no, what happened? What is going on? No. Oh my goodness, you stupid thing. What just happened? Okay, great. Boy, of course it's the last video of the day. I've been doing this for about 10 hours, so that's why this happens. Okay, here's my circle of radius 5, hopefully. And my concentric unit circle of radius 1. Okay. Oh boy. Okay, so now let's say I have a vector v. Let's do the vector in orange at 4, 3. So this is my vector v at 4, 3. So let's say v is 4, 3. Maybe I need to move this down a bit. Let's change the color of v. Let's make it yellow. Here's vector v And of course, vector v is written as 4, 3. Okay, so the coordinate at the terminal point of v, well, what do I have? I have that x squared plus y squared is equal to 5 squared. That's the blue guy. But now if I divide everything by 5 squared, what I get then is x over 5 squared plus y over 5 squared is equal to 1. Actually, let me change this color to hot pink so that you'll see where I'm going with this. X and y each over 5 is equal to 1. Okay, so that's the unit circle equivalent. So what am I saying? I'm saying that the coordinate here is going to be the x coordinate, which on v was 4, and the y coordinate, which on v was 3 all over 5, because that brings me back to the unit circle. Okay? Okay, so definition. Definition. What I've created there is a green little vector here is termed a unit vector because it's on the unit circle. Okay, so the unit vector in the direction of v, so in the direction of vector v. So notice we had vector v here in yellow, and the unit vector green was in the same direction as vector v. Let's say v is a comma b is given by, so we'll call it u for unit vector. And basically I just take vector v and I divide it by its magnitude. Is a 3, 4, 5 right triangle, does that have magnitude 5? It does. So all I did was I took 4, 3 and divided it by 5, each component, to get to the unit circle. Okay, so let's note the terminal point of a unit vector is on the unit circle. So note the terminal point of a unit vector in standard position. So what do I mean by standard position? That is, i.e., with initial point at the origin, So the terminal point of a unit vector in standard position lies on the unit circle. Hence, a unit vector on the unit circle. S1. Okay, so I think we can finally do our last 3 examples. So for example, so let's find the unit vector in the direction of v. So find the unit vector u in the direction of v. So in the direction of v. For the following. Okay, so number 1, let's say we're given that vector v is negative 5 root 3, comma 5. Okay, so the first thing I want to find out is the magnitude of v. So the magnitude of v, of course, is the square root of a squared plus b squared which is going to be the square root of quantity, negative 5 root 3 squared, plus the quantity 5 squared. Okay, so this gives me the square root of 25 times 3 plus 25. So I have 4 25s. 4 25s underneath the square root comes out as 2 times 5, or 10. Okay, so that's the magnitude. So I now know that vector u, which is vector v divided by the magnitude of vector v, is simply going to be, actually let me keep this here, vector v, which is negative 5 root 3, comma 5, divided by 10. So that means I just take each component and divide it by 10. So I have negative 5 root 3 divided by 10, comma, then I have 5 divided by 10. And hopefully this will look familiar. Hopefully it'll be on the unit circle. And this indeed simplifies because the 5 over 10 reduces to 1 over 2. So what do we get? We get negative root 3 over 2 and 1/2, which is definitely on the unit circle. So we're set. So that is the unit vector in the same direction as v, but on the unit circle instead. Okay, so let's do another one. So number 2, let's say I give you that vector v is equal to 5 comma negative 12. Okay, so the magnitude of vector v is going to be the square root of a squared plus b squared and for those of you who are savvy, you see that this is a 5, 12, 13 right triangle. This is 5 squared plus a quantity negative 12 squared so that's a square root of 25 plus 144, which is 169. Square root of 169 is 13. I guess I'll write it out, 169, and that gives me 13. Okay, so my radius or magnitude is 13. So vector u is going to be vector v divided by the magnitude of vector v. Okay. So that gives us 5 comma negative 12 divided by 13. That means I can push 13 into each component. So this gives me 5 and negative 12 both divided by 13. And yes, this is on the unit circle because it's a 5, 12, 13 right triangle. Okay, let's do another one. Number 3. Let's say we have vector v is equal to 3 times the square root of 2, comma 3 times the square root of 7. Okay, so once again, the magnitude vector v is the square root of a squared plus b squared okay, so that gives us quantity 3 root 2 squared plus quantity 3 root 7 squared okay, so what does that give us? Gives us 9 times 2 plus 9 times 7. So that's 9 times 9 because there's 2 plus 7 is 9 nines. So square root of 9 times 9 is 9. Okay, so therefore the unit vector in the direction of v is going to be v divided by the magnitude of v. So vector v divided by the length or radius or magnitude of v. Okay. Okay, so vector v was 3 root 2, comma 3 root 7, all divided by the magnitude was 9. Okay, so I take each component here and I divide it by 9. So I get 3 root 2 and 3 root 7 divided by 9. But of course this reduces because 3 goes into 9 3 times. So when all is said and done, we get root 2 over 3, comma, root 7 over 3. Actually, let me just, no, I'll write it root 2 over 3 and root 7 over 3. And we just have to trust it's on that's on the unit circle. And we could test that by using the Pythagorean theorem. Okay, so there we are. That's how we find the unit vector in the same direction as vector v.